Uh, Hello friends, in this video we will see about vectors and vector spaces uh, and a system of linear equations, linear homogeneous and linear non-homogeneous equations with based on matrix and vectors. So first, vectors can be represented as x1, x2, x3 within square bracket, or y1, y2, y3 within square bracket, uh, within brackets. So these two things are two vectors. So if this is going to be represented in this way, then it means that vector is in three dimensions and it has three tuples. And if a vector is going to be linearly dependent, then it means that a into x1 comma x1 plus x2 plus x3 plus b into y1 plus y2 plus y3 equal to 0. That is, it can be combined with a scalar in order to nullify its value. If this is the case, then the vectors are said to be linearly dependent on each other. In other way to express this one, there exists some value scalar which when multiplied with the vector and added with the another vector which is also multiplied by another scalar yields zero value. So this is the case, means then they are linearly dependent on each other. So vector spaces is a set of elements often called vectors may be added together multiplied by numbers called scalars. That is what vector spaces is all about. And row echelon matrix. So row echelon matrix is obtained as a result of Gaussian elimination. Gaussian elimination is when we do some arithmetic operation after we have the matrix from one row onto the another, then we eliminate one row elements by doing addition or subtraction based with a scalar. If we do that one and we are able to eliminate some elements, that is make the values as 0, then it is known as Gaussian elimination. If we have an echelon matrix is something which has it's a triangular matrix. Below the diagonal element, if the elements are going to be 0, then it is called as upper triangular row echelon matrix. If below the diagonal the elements are going to be going to have values, and above the diagonal the values are going to be 0, then it is called known as lower triangular row echelon matrix. Next we are going to see about rank of a matrix. So dimension of the vector space generated as spanned by its column. This corresponds to maximal number of linearly independent columns. So linearly independent columns, if the columns are going to be linearly independent of each other, and whatever the total number of columns which are linearly independent, that is going to be said as the rank of the matrix. Linearly dependent ones will not be considered for the rank of the matrix. So what is the purpose of this rank of the matrix? It is useful in providing insights into the solutions of the system of equations that matrix represents. So for example, there is a matrix A which has the value, it's a 3 by 3 matrix. It has the value 1 0 1 0 1 1 0 1 1. This matrix, even though it has 3 rows, its rank is 2 because the first two columns are linearly independent, while the third column can be expressed as the linear combination of the first two. That is, when column 1 is added with column 2, we get 1 1 1. So this third column is a linear combination of the first two columns. Therefore, the third column is not considered for the rank of the matrix. Only the first two columns are considered for the rank of the matrix. This rank is known as the rank of the matrix. This can be said similarly with the rows as well. Rows rank of the matrix can be determined by on similar basis based on rows, and it has been found that the rank determined by rows is equal to the rank determined by columns. There are many proofs that have been given. Next, what the range of the matrix, like Ax equal to b, if this is the case, then the range of the matrix info is covered in the rank of the matrix as well. A set of values x1, x2 up to xn are said to be the solution of the system in the matrix case. So when the system of equations has a solution, it is said to be consistent. Otherwise, the system is said to be inconsistent. So if rank of a matrix doesn't equal to rank of the augmented matrix A comma B, then the equations are inconsistent. If the rank of the matrix equals the rank of the matrix augmented matrix A comma B, that is also equal to the number of unknowns, then the system is said to be consistent and has unique solution. An example is if A has the vectors 1 3 5 3 2 1 and 1 3 2. These are there are three vectors which A has, and there are three unknown variables. And suppose if the rank of the matrix is going to be 3, and the right and the augmented matrix A comma B will have whatever the values, that is 3x plus 5y plus 2z equal to 8, means that 8 value based on all the three things will be 8, 5 equal to 8 equal to 5. Those values will be considered as B and it will be added along with A. So this will form the augmented matrix A comma B. So now after forming the augmented matrix A comma B, we determine its rank and then we compare it with the rank of the matrix which doesn't have A. So this rank, the A matrix is called as the coefficient matrix and A comma B is called the augmented matrix. So then these two ranks are compared with the number of unknowns, that is x1, x2, x3. So if all these three are equal, then it is consistent and has unique solution. So there are three methods in which we can determine the linear independency of a matrix. The first method involves use of some variables like k1, k2, k3. So for example, x1 is equal to 2 comma minus 2 comma 1 and x2 is equal to 1 4 minus 1, x3 equal to 4 6 minus 3. Then we have to multiply k1 into 2 minus 2 1 plus equals 0, or k1 into 2 minus 2 comma 1 plus k2 into 1 4 minus 1 plus k3 into 4 6 minus 3 equal to 0. So we will do these kind of calculations over there, find out the value of k1, k2, k3, and then we will see if k1 equal to k2 equal to k3, then this is linearly independent, we will say. The second method is reduce the matrix to echelon form, that is upper triangular echelon form or lower triangular echelon form, that is below the diagonal or upper over the diagonal other elements are 0. Then the number of non-zero vectors will be determined, which if it is equal to the number of given vectors, then they are linearly independent. Method 3, if the matrix determinant of A matrix is found out, if it equals 0 and the rank of A matrix is found out, if it is not equal to number of unknowns, then we will tell that they are linearly dependent on each other. So this is how the matrix, based on matrix, the determining the system of homogeneous linear independent equations or dependent equations is done. Thank you.